So once we have a design and we understand the threats, then as you see in this ladder here, going from the devices at the bottom, these are all the things that we need to protect. And so our architecture, once we've decided what needs to be protected, we needed to put in place some technology, some system that'll make sure that the device is protected, its identity is protected and can't be cloned, that all of the data is secure end-to-end, that the decisions that it's making are also secure and can't be tampered with, that the commands that that device is executing, and this, especially in the case of brakes on a car, are authenticated and are allowed to be executed, as opposed to, as we saw in the Jeep exploit, where someone got in and was able to activate the brakes through their Bluetooth stack. And last but not least, that those actions then, like the braking, are secure. This isn't a trivial matter, and really it all starts with what you see at the top, and that's creating an identity in that device that is immutable, can't be changed, can't be duplicated, can't be cloned, and is then the foundation for every security use case that you see here. That's what we refer to as a hardware root of trust. It can also be software-based if the situation allows for it. And that's what creates that end-to-end trust in the case of data, for instance, from the point that the data is produced to the point that it's used by a back-end application. One of the mistakes we see people doing today is they're only encrypting the communication link. What about within the device itself when that device is in hostile territory out in the real world? The data within the device at rest also needs to be securely processed, securely stored. AI, for instance, is increasingly being used in edge-based decision-making. Well, those algorithms are important intellectual property, which means you want them, if you're the one who's created them and owns them, to be protected from tampering and from theft. Those decision-making processes are also using data that if that data doesn't have integrity, if it's not authentic, it can't be trusted anymore, and the decisions that will be made based on that are going to be wrong. So the message that I want to leave with you here is that if you have an IoT ecosystem, which is fundamentally based on things, on devices, then the security needs to start in the thing itself, so that everything that happens up this chain, up these steps, after that is secure. And that includes commands coming down from the cloud, that includes new firmware updates coming down, all of these things of critical importance. And you can see, I'm not going to go through in detail in the coming slides, but they'll be available for you in the recording afterwards for you to look at in more detail. Device identity and security is key. We need to provision at the point that a device is created. We need to make sure that we can seamlessly identify these devices when they connect by their unique identities. We need to be able to do zero-touch provisioning and cloud onboarding so that when a device connects to the network, the backend knows exactly what that device is, knows that it's authorized to connect, and knows it can trust that device and all the data coming from it, as well as a number of other important security use cases, as we would call them. In addition, if IoT is about devices, it's also about data at the end of the day, because that's really the purpose of the Internet of Things in the first place, is to get that critical data so that we can understand it and make smart decisions based on it. So the end-to-end encryption I was discussing earlier remains critical, the secure local storage, the being able to not just secure end-to-end, but also over the communication network if desired. And within a device itself, if it is a really critical application, then how are we securing the data and the communications between the different chips in the device as well, is something that should be considered. Last but not least, as that data flows through the ecosystem, how do we make sure that we control, using fine-grained policies, access to that data, access to the device, and how do we activate and deactivate features on that device so that we can create exciting new business models, like upselling features on devices that people have already bought, like we see today, for instance, Tesla doing with various different services in their car. And then last but not least, this establishing a secure root of trust needs to enable the ability to update it over time as security situations evolve. as the threats evolve, needs to be able to have a smart, efficient key management and key renewability system so that the security of the device, the data, the decisions is all robust. And then you need to be able to securely update the firmware of that device over time to make sure that it's never taken over by malware, et cetera. So that's a lot of detail on the technical side, because that's sort of where our history as a company is and where we specialize. But I hope that you can see that by establishing that hardware or software-based root of trust in the device, that it enables all these different security use cases that are critical to IoT.